Welcome to our CS 364 discussion on entity relationship diagrams, presented by John Bake and Nathan Stratford. In this presentation, we will provide you with a description of what ERDs are, how they are used, some advantages and disadvantages, when they are appropriate to use, and finally an example of how they could be used in the Grad Planner project. So what is an entity relationship diagram, or ERD? An ERD is a form of flowchart that is designed to communicate how different data types within a piece of software relate to one another. They are generally used to represent the structure of a database. A good way to picture it is as a sentence where the entities are nouns and the relationships are verbs that explain how the two nouns interact. For instance, a student and a course could both be entities. The verb that would connect them might be enrolls, as in a student enrolls in a course. The ERD gives us a visual representation of this relationship. Additionally, the ERD provides further information about the relationship by showing the attributes of each entity, such as name for student and ID for course. We can also show the cardinality of the relationship. In this case, we might say that this is a many-to-many relationship because many students can enroll in one course and one student can enroll in many courses. There are multiple notation styles that can be used to create an ERD. Some of the most common are the Chin, named after one of the creators of the ERD concept, the crow's foot, which we will use in our examples, and the Bachman and IDF1X. To communicate all this information in a crow's foot ERD, we place each entity in its own box with any attributes shown below in a separate section of the box. We then connect each entity to the ones it relates to with lines labeled with the relationship. Here's a quick example of an ERD showing all the parts we have discussed. In this example, each entity is shown in its own box with its corresponding attributes. The relationships are shown as the lines between each box. The label for the relationship is placed at the end of the line. The symbols at the end of the lines represent the cardinality and whether or not the relationship is required or optional. For instance, each product has an associated name and ID. Each color has an associated ID. The relationship between them is many-to-many and required. Each product comes in many colors, and each color is used by many products. In the Grad Planner project, ERDs could be used to help organize the flow of data. In this example, we've created a simple ERD at the conceptual or highest level of detail. We have three entities: student, grad plan, and course. Each entity has several attributes associated with it. Student has an ID, password, and course. The grad plan has a student, course, and semester, and the course has subject, teacher, and title. Each entity is also related to the other two. The student creates one or many grad plans. The grad plan belongs to one student. The grad plan contains many courses, and the course belongs to one grad plan, while the student enrolls in one or many courses, and the course belongs to one student. Using ERDs in this manner would allow our team to design the structure of the data needed to achieve the functionality specified in the requirements. Often, more than one ERD is required to adequately document the many data relationships in a piece of software. For this reason, three different levels of detail are generally employed. The conceptual data model is the least detailed and may not be necessary for projects with a smaller scope. It reflects the overall architecture of the system. The logical data model will be used to show the operational details of the data structure. However, it needs to be independent of the technology used to implement it. One or more physical data models are generated from each logical model. These would be the most detailed models. They contain the technology detail needed to actually create the database.
There are many useful advantages to the ERD. One of the most obvious advantages is the easy conversion to database tables. From the picture we presented before, you could see many tables organized in a layout of different entities. So you have different products, objects, along with their properties. Having this layout, it is very easy to take the properties from each thing and convert it. You can see where each property would go into a row of a specific column of a specific entity. That is very easy conversion from that point. You can logically take the table that you have given in front of you and then bring it over to a relational database. It is an excellent visual representation. It explains really well the conceptual side of a relational database. It is very useful. And it's in an educative purpose. It's very easy to explain to someone using this model, making it very easy to understand. While there are many advantages to an ERD, it is not without its drawbacks. Basically, from what we see within the entity, within the images that we were looking at before, you see the specific entities with their specific properties all within a relational database. Now you can have a lot of data that is not structured in this way, like without a relational database. If you do not have a relational database, you can't really represent the data in an entity relationship diagram. It wouldn't work simply because the whole diagram is based on the objects and models connecting to each other in some way. For example, before in the example we had a grad plan has a student, or many students, sorry, and the student has its own properties. And a student could have many courses, and the courses have its own properties, and thus you can see how it connects. If it is not within a relational database, you can't really represent the structure of it in that way. So therefore, you cannot represent unstructured data in that way as well. And that, along with those lines, it is very difficult integrating it with an existing database. Nearly, it's very complicated simply because you already have something existing there. It's unorganized, and you have to figure out a way to basically, if you create a diagram, you have to incorporate everything that's already there, which cannot have a structure. So those are a few drawbacks of it. There are many different uses of when to use an ERD. One of the most common, as we have been discussing, is a database design, especially within those relational databases. Every entity with its properties can represent different tables, and each table within those properties, the entity itself can be a column, and each property can be different rows within those columns. And that is just a very convenient way to display it, and it's also easy to understand. And this also aids within the database troubleshooting. So if you ever have an error, you can easily debug through different, if you have, for example, a model of student, you know right away the different properties of that student, and you can troubleshoot and look for the values of those keys. For example, of an ID, you know right away the different properties a student may have. For business information systems as well, the same kind of principle. When it's already organized in the relational database within a business information system, you'll have different properties highly related to each other. There's a lot of connections right there. For example, customers and accounts with different numbers. There's a lot of overlap. Whenever there's a lot of overlap in a situation like a business, it is always very useful to have an ERD. Same thing if you're re-engineering a project. You'll have basically the ERD there, and it's very easy to manipulate the data that you already have. As far as educational purposes go, in education, like we're doing a grad planner, it's very useful to have an ERD, simply because of the nature of students having courses and within the grad planner. In conclusion, an ERD is very useful when you have a relational database and when you basically have just very structured data. If you do not have structured data, it is better to use a different method. But overall, if you want your project to be organized and efficient, it is best to use this method and have a relational database as well.